How does a machine know how fast it's spinning? How far something moved or when to stop at a perfect position? The answer is simple: an encoder. An encoder is a sensor that tracks the motion. It measures things like position, speed, and distance, and it sends the information to controller like PLCs. So encoder sends signals to the controller, and those signals are converted into useful information that program can understand and use. There are different types of encoder technologies: magnetic, mechanical, resistive, but the most important is optical because it's very accurate. Before we start talking about what is an optical encoder, how encoder is used in a practical different industrial applications, and what are the different types of encoder. If you're new to the channel, please hit the like button, subscribe if you haven't yet, because we would try to create more amazing content like this one related to PLCs, DCS, SCADA, and HMI. Let's get back to the topic. An optical encoder works using light. Inside there is a spinning disc with a pattern like tiny lines. A light shines through the disc, and as it spins, the light gets blocked and unblocked, like opening and closing a shutter. On another side, sensor reads this pattern and turns it into electrical pulses. Each pulse represents a moment. More pulses is equal to more moment. Faster pulses mean higher speed. That's how a system understands what's happening. There are two main types of an encoder: incremental and absolute. We would definitely talk about that shortly. Before we talk about the difference between incremental and absolute encoder, let's try to focus first on industrial applications of an encoder. Let's say you are running a pump with motor. You set a speed. How do you know it's actually running at that speed? That's encoder. That gives you a real-time feedback so that system can adjust and stay accurate. Now imagine cutting material to a specific length. The encoder tracks how far the material moves. Once it reaches to the right distance, the machine cuts. Simple and precise. Here's a more advanced example. Bottles move through machine. You need to make sure every bottle that enters also exits, and within the right amount of time. The encoder tracks movement along the conveyor. By comparing the counts at the entrance and exit, system knows exactly where each bottle should be. Even if the bottle shape changes, the system can still track it correctly. At the core, it's very simple. First you count the moments, then you compare the values, and then you make the decision. Now let's talk about what is the difference between incremental and absolute encoder. Let's talk first what is incremental encoder. It measures the moment change, sends the pulses as it rotates. Its position is actually counted from the starting point. So key idea here is, if your power is lost, position is lost. Think of it like this: a step counter only knows how far you have moved, not where you started. Now let's talk about absolute encoder. It measures the exact position. Each position has a unique value. No need to track from the starting point. Key idea here is, if power is lost, your position is still known. Think of it like a GPS. It always knows exactly where you are. So in one line summary, incremental tracks the moment, absolute knows position, and accurate one. That's all for today. If you like this video, consider hitting the like button, because it's very motivating. If we see a lot of people appreciating the content, that's more valuable, and that's kind of a motivation that keeps us going to create more amazing content like this. So if you haven't subscribed this YouTube channel, consider subscribing, turn your notification on, because believe me or not, you will see amazing content related to PLCs, DCS and SCADA. Until next time, take care, goodbye and Allah Hafiz.